just explored this right here. How many of those pyramids of the same base and height of that cube fit inside of there? 3. So we're going to start looking at volumes of pyramids. And again, guys, nothing very different, all right? Nothing very different. Can we get that door for me, buddy? Can you get the door for me? All right. So volumes of pyramids. Volunteer to read my essential question. Who wants to read that? Anybody?
How do you find the volume of a pyramid?
How do you find the volume of a pyramid? So what are the goals that we're looking to accomplish today?
Find the volume of a pyramid.
And then we're going to use them, okay? I don't think I need to describe what a pyramid is. We just looked at one right there, but we'll make a sketch of one. Guys, pyramid is a structure whose outer surfaces are what?
Triangle.
And converge to a single
Point.
at the top, making the shape roughly a pyramid in the geometric sense. The base of a pyramid can be what we say trilateral, quadrilateral, or of any polygon shape. In our example right here, our pyramid that we used in the experiment, what shape? Square. The base of the end can be a triangle, could have been a pentagon, could have been an octagon, whatever. But you guys recognize pyramids mostly to look like, let's draw a picture up here. Maybe you can make a sketch of it. But most pyramids, look like this, and you can sketch this real quickly. Here's like, what kind of pyramid do I have here? I mean, you would draw a hexagon and then pick a point up here and then just draw stuff to it, okay? I'm going to put up here, I don't know, is there a square pyramid? I'll put the square pyramid up here for you. That's kind of what they look like, okay? So you know that. You can try to draw that, that's fine. I don't care if you do or if you don't, all right? And then the last term that we really need to kind of talk about is what's a composite solid. You guys remember an example on the last section where we had the cylinder and we pulled the triangular prism out of it? We said that was a composite solid. Yesterday you had a quick quiz on that. Okay, it had a rectangular prism and on top of it was a triangular prism, and you guys did a really good job with that. Things you're going to see today for composite solids might look like this. You might have, look up here everybody, you might have this cube as part of it, but on top of it might be triangle. Okay, so if I had to say what's the volume of the whole thing, that's like the volume of a cube plus the volume of a what? Okay, so you might have to add volumes of maybe prisms and pyramids together, okay? And we'll look at some examples. So you'll see some prisms, you'll see some pyramids. Whoops, I spelled that wrong. Pyramids together, all right? So composite just means you're taking two different shapes and combining them to get a volume of a totally different shape. So give me a second to get that down. You guys good with that? All right, so Sonny, it looks like you looked ahead of the core concept. What's core concept say?
Volume being a pyramid is V equals 1/3 times base times height, and B is the area of the base and H is height.
Okay, so B is going to be the area of the base. In most cases for pyramids, it's going to be the bottom now, okay? The height, guys, the height is a vertical height. Typically, it's an inside height. It's not a slant height, but it has to be a vertical height. An alternative formula, I like the one I'm about ready to put up here better. I like doing volume equals area of the base times the height divided by 3. Isn't 1/3 of something the same as dividing by 3? Okay, so I kind of like to use that formula a little better. Again, why the 1/3? Where did the 1/3 come from? 3 pyramids fit into its cube equivalency with the same base and height. Right? Well, let's jump ahead. Let's see if we can't figure this out. Guys, the height you always want has to make a 90-degree angle with the base. Is this height of 2.4 meters making a 90-degree angle with the area of my base down here? It says finding the volume of a pyramid. Help me out, kids. First of all, what shape does a base appear to be in this pyramid?
Square.
Secondly, check your units. Do your units appear to be of the same unit?
Yes.
Meters. I going to find capital B in this case.
4 times 4.
Since it's a square, it would be 4 times 4. These tick marks indicate equivalency. So B would equal 4 times 4, which is what?
16.
Okay. How about my height? Do I have the proper height, or the height that's perpendicular to my base? 2.4. My goodness, that's great. Could I find the volume given the base and the height now?
Yeah.
My volume would equal 16 times 2.4. But since it's a pyramid, what you gotta do now?
Divide by 3.
What do you guys think?
12.8.
You guys get 12.8? We all agree 12.8? Still talking volume, kids, so 12.8. Okay, so 12.8, and we'll call it cubic meters. Looks like meters cubed, red cubic meters. Is there anything really new here today, kids? You're still finding the area of a base. You're still looking for a perpendicular height to that base. The only difference is you've got to recognize if something's a pyramid, your last step today is to divide by 3. All right, you guys try to talk me through example 2. Let's see what we can come up with here, kids. How about a volunteer to read 2, and we'll see if we can't.
A square pyramid has a height of 12 centimeters and a volume of 64 cubic centimeters. Find the side length of the square base.
Okay, so first of all, what type of pyramid, kids? So this length right here, I don't know, I'm going to call it x. That means this distance down here would also be what? That'd be x also, wouldn't it, kids? They said the height here from here to the middle, how much? To the middle of that base, kids. What's the height?
12.
Okay, we have to find the length of each side, okay? All right, in this case right here, are we dealing with a pyramid or a prism? So what I'm going to do here is this, kids. My volume is going to equal the area of a base times my height divided by 3. Let's plug in what we can plug in. Do you know the volume first? So what could you replace V with? So 64 equals. Okay, do we know the area of the base? Is there a way to express the base the way we've diagrammed this, though? X to the what? Yep, somebody said x squared. The base would be length times width down here. So the base would be x squared. Hey, quick question, kids. Do we know the height?
Yeah.
All over what? Okay, let's work from here. Guys, how about this 12 over 3 part? What's that become? So do you guys agree that the right is like 4 times x to the second power? Okay, so I've got from here, 64 would equal 4x to the second. Gosh, I want to find that edge length x. What do you think my next step is trying to get there? Not square rooting yet. Divide by 4. Actually, in this one, square rooting wouldn't be a bad idea, but we'd have to recognize that 4 is a perfect square and 64 is a perfect square. But square rooting, let's save that idea. Let's divide by 4 first. Are you okay with that, Layton?
Yep.
If I divide 4, kids, 64 divided 4 is? That equals x squared. Oh my goodness. What's x equal?
4.
Check it, kids. Who has a calculator handy? Joey, go 4 times 4 times 12. How much?
192.
192, but since it's a pyramid, divide that by 3. Does that match the value we had? So is 4 correct? All good with this stuff so far? Nothing really different. Last step, divide by 3. You've looked at saying, hey, here's the volume, find a missing dimension. This is the same concept. I gave you a volume. I always think it's important to start out with your formulas, plug in what you know, work your way through it. So, we're pretty good with pyramids that have square bottoms, right? Are all pyramids going to have square bottoms?
No.
We said the base can be any shape, any polygon. What's the base shape in this pyramid?
Triangle.
Ooh! like kind of like this? This triangular pyramid by base shape is what? Not look exactly like it, but the base shape of triangle is in a pyramid. Do all the faces are triangular shape? Meet at a point. Okay, triangular pyramid. Find the height of a triangular pyramid. Oh my gosh. Well, again, I always think it's important to write out what when we start these. All right, so let's write the formula. The formula we're using, kids, volume equals area of a base times the height divided by, you guys help me. Do we know the volume in this?
Yes.
What is it?
384.
So from here, we're going to say 384. Okay. What shape is a base again?
Triangle.
Do you know the base?
No.
Is there enough information there to come up with a base?
Yeah.
How?
Only 4 times 8 divided by
Yeah, you guys see down here? If I would highlight this triangular part right here. Boom. Boom. That triangular part right down there. Height in there is 8, base is 24. So you're telling me capital B in this would equal, since it's a triangle, half times 24 times 8 again. Is that right? Is that what you said, Grace?
Yeah.
Oh boy, my North of Highway 3 math skills tell me that's 96. Is that right?
Yeah.
Okay, so volume 384. This was 96 for capital B down here. That's going to equal 96 times, do we know the height?
No.
That's what we're looking for.
Yeah. No, you don't.
We can find it though, can't we? Hey, take a look at the right side. I've filled everything in that I can possibly fill in. What about that 96 over 3? Can that simplify?
Yeah.
So call this 384 equals what? 32H, right? Okay, you guys run the numbers. What do you guys get? 384 divided 32. 12. Height's equal to 12. It's a linear unit. Everything was measured in what unit here, kids? What do you guys think? If you start with a formula, plug in what you know, can you handle it? Yay or nay? Questions to this point? Anything really new? The only change today is what? We've got the division in 3 as part of the process or part of the formula. That's all it's different. Okay? Questions so far, kids? All right, moving on. I like this one. Example 4 is very similar to things that we've looked at in the past. Okay? How about a volunteer to read example 4?
Square pyramid A and square pyramid B are similar. The height of pyramid A is 6 inches and the height of pyramid B is 15 inches. The volume of pyramid B is 312.5 cubic inches. Find the volume of pyramid A.
All right, so I'm going to set this up as maybe pyramid A and pyramid B. Who's got the hiccups? Do you need to get a drink? You can if you want. Guys, when I give a height, is a height a volume or is a height like a side ratio?
Like a side ratio.
Okay, so what was the height of A? What was the height of A, kids?
6.
Whoa, what happened there?
Uh-oh.
A is 6. What's the height of B?
15.
Okay, now 6 over 15, kids, simply put, that's a side ratio.
Yeah.
We're talking about volumes, finding volumes. So what do I have to do to a side ratio before I can use a ratio to find volumes?
You got cubic.
Okay, so this side ratio is 6 to 15. We want to take this side ratio and do what to it now? Side ratio to the third would get us a volume ratio, right? So my volume ratio is as follows. Help me out, kids. 6 to the third, I think that's 216. Is that right? Ah, boy, don't test me on 15 to the third, but is that 3,125? 3,375? Close. Guys, it means for this. For every 216 cubic units I throw into pyramid A, how many am I throwing into pyramid B? Okay. However, the problem simply says you have to find the volume of A, given that the volume of pyramid B is what?
312.5.
Okay, so if I take my volume ratio and make that part of the proportion to solve this, where's that 312.5 going to go, kids? Yeah, it's part of pyramid B, so I have to put that 312.5 on the bottom. My answer better be smaller than 312.5 because we're looking for the volume of the smaller pyramid. Somebody want to cross multiply that and divide that for me?
20.
Okay, so the volume of, what was it, pyramid A?
Yes.
Did you say 20 is what you came up with, kiddo?
Yeah.
And it would be 20
inches.
cubic inches, right? Very good, guys. I have a question regarding heights as a side ratio and volumes of a pyramid. Did anything in that process about taking side ratios and turning to volume ratios change compared to what we did in the last section? Did anything change it? Nothing. Exactly the same process, okay? So when pyramids are similar and you're looking for unknown volumes, you treat it exactly the same. Find your side ratio. Do what to the side ratio? Cube it. Set that up as a volume ratio. Plug in your known volume as part of the proportion. You cross multiply and divide. You're on your way. Okay. Guys, I think you're rocking and rolling this so well today. I think I'm going to give you an example 5. I want you guys to find the volume of this. I want you to try this on your own. See what you get. Give you about 2 minutes here. When you've got an answer, check with the neighbor, see what you get for a volume, and then we'll come back together and talk about this, okay? Okay, anybody have an answer here? Almost? 1776, you said? That was a pretty important year. Right? Especially like July 4th or something like that, 1776. How many got 1776? How many think 1776 is right? How many are not sure 1776 is right? How many have thoughts on how to find the volume of this? Okay, what's the bottom solid going to be? Is the bottom solid a prism or a cube? Or I'm sorry, a prism or a pyramid, I'm sorry. It's a prism, right? Rectangular prism, can't I just do length times width times height for the bottom? Let's do that. The bottom, guys, help me out. Any rectangular prism, you should know length times width times height. Do you guys see the bottom here? 12 by, what's this distance right here? 12 by a height of what, kids? Yeah, bottom is 12 by 12 by 9. Okay, run that number and we'll bank it. 1,296. Okay. I'm a little concerned about your top here, kids. There's a curveball they threw at you, and it wasn't very nice of them. Okay. First of all, what shape is the top? Okay. Do we know the sides of this square pyramid? 12 by what? My question is, kids, do we have a perpendicular height to the base, or do we have something else? You have a slanted height in there, don't you? And the trick behind it is the following, kids. We need to know the height that's in here, in the middle. Okay, you need to know the inside height. Because think about it. What does volume measure? Does it measure stuff on the inside or the outside? We would want to know the inside height of that. Okay? Guys, I don't know what this height is right here, but what I can tell you is this. It goes right to the middle of that. Think about this. Kids, what's this distance down here again? So if I knew that this hit perpendicularly right in the middle, what would the distance from here to this be out here? Quick question. You got enough information to find the height looking at this triangle right here now? You would do 10 squared minus 6 squared to get you an inside height of what? That inside height is 8. So talk to me about how we're going to find the volume of the top there. 12 times 12 times 8, right? Huh? Why divide by 3? Top part's pyramid, you bet. So I've got to do 12 times 12 times 8. Where'd the 8 come from again, kids? It's the inside height. You were given a slant height. You needed to know the inside height. Kids, I have no idea what 12 times 12 times 8 is. And then divide that by, what do you get? Say again. 384. Layton, can I ask you a question?
Yeah.
You're 1776. Did you use 10 as a height?
Yeah.
Okay. See the difference here? Okay. And again, I want to point that out. I kind of figured you guys might go.
Wait, so how'd you find 8?
Okay. How did I find 8 again, kids? Okay.
10 squared minus 6 squared.
Yep. So if I drop this height right in here, you agree it goes right to the middle, right here, right?
Yeah.
Okay. Do you agree that this distance down here is 12? So if that distance is 12, the distance from here out to this edge would be half of that, which would be, so I see a right triangle right here. The hypotenuse is at 10. 10 squared minus 6 squared turns out to be 64. Okay. Good now?
Yeah.
So what is our volume here, kids? What is that total volume? Say it louder for me. 1,680. What type of unit should we choose to attach to this? Cubic meters. Okay, very good. Okay, guys, we've got about 20 minutes left here. I want you to take a look at those peer evaluations. I want you to check your answers with me before you leave today. I'm going to send out your new online here while you're doing the peer evals, but talk these over, have good discussions. If you disagree about what you're working on, talk about why you disagree. Otherwise, don't forget the stuff from 11.4. We'll grade that when? Tomorrow. And then if you're all done with 11.4 stuff, get into the 11.5 I'm about to send out, okay? Kids, what questions do you have this morning? Pretty easy? A bunch of hippy-dippy baloney, isn't it? You guys rock. Keep up the good work, okay? Oh, let me stop this.